Hi, my name's Desiree, and in this video, I'm going to be going over cell membrane, the functions, kind of just how it looks, and the relation of diffusion and osmosis. So, our cell membrane is a selectively permeable phospholipid bilayer. What that means is that it's going to direct what can come in and out of the cell, and the phospholipid bilayer is just it's two rows of what we can see here, my rough drawing of a phosphate group and two fatty acid chain. So the phosphate group is water soluble. So it's going to be the one that's facing the outside. And then the two fatty acids is water insoluble. So it's kind of going to be facing the inside, giving us this kind of phospholipid bilayer where everything's protected going in. And our cell membrane can be looked up as a fluid mosaic model because it has a lot of stuff in there to kind of help keep the rigidity and structure of the cell membrane, hopefully keeping it from collapsing in on itself. And by that, I mean we have cholesterol that can be within those fatty acid groups to help with that structure. We have different proteins too that can help us. They can also be on the cell wall to help other cells either bind to it, get receptors to send certain signals. We can have carbohydrate chains that helps us, and that if there's a certain cell with a certain marking, it can bind into it. Also, we have channels, and we have big channel proteins so that because with water and certain other substances that can just diffuse in and out of the cell, we want to also make sure that stuff that's bigger than that can't just come in and out as it pleases. So then we have these channel proteins that can help bring stuff in. So like I said, this is outside the cell and this would be inside the cell. So we have that chain to bring in those bigger substances. Most channels would be the calcium, sodium, potassium, and chloride channels. And these don't always have to be turned on. They could be like a certain time frame, snap in, snap off, either push things out or bring things in real fast. But most of the time, our cell membrane is just doing diffusion. So diffusion is just a solute moving from an area of higher concentration to an area of lower concentration. Here you can kind of see, we can kind of say that maybe this is a cell. There's that membrane. Inside this cell is more of that negative energy, my little negative signs. So on the outside, it's more positive. So when they come into contact with each other, they want to balance out after. So everything in here is just going to move out and diffuse slowly. So then we can get to a isotonic state where we have equal amounts outside of this membrane as what's inside the membrane. All cells do this. It's very important that our cells do this with carbon dioxide and oxygen, because our cells make energy and do perform its function. It's gonna make CO2, and if there's a buildup of CO2 to the point where we can't get any more oxygen, the cell dies. So we want it to be easy to get in and out of. So how our bodies do that is that, say like this is at the capillary. So our blood flow through the arteries is coming out with high oxygen, low CO2. And like I said, our cells do its job, create CO2, and then have low O2. So we want oxygen in the cell so that we can keep performing our job. So when it comes into contact with this vein, because we have that low CO2, the blood flow kind of just brings it through, puts more O2 in there, and then we have the CO2 coming out into our blood so that our blood can take all the CO2 that our cells give off, take it through our body, and then reoxygenize it so that we can use it for more energy and keeping the body alive. Thank you.